So in this lecture I will teach torque equation of DC motor. Whenever current carrying conductor plays in a magnetic field, it will experience a force. That is our DC motor principle. With that force, the torque will be produced. A torque definition is a turning force about an axis is called torque. So if you a wheel is connected to the shaft of DC motor and the wheel radius will be R. Suppose if will be rotates in a clockwise direction, that means armature is rotating in a clockwise direction. The force which is developed, it is in the downward direction. So the consider a wheel of radius R meters acted upon by a circumferential force. This is called the circumferential force in newtons. Then the angular speed of the wheel, omega is equal to 2 pi n by 60 radians per second. Omega is equal to 2 pi means radians per second. Then work done in one revolution. Work done in one revolution is W is equal to force into distance travelled in one revolution. So the distance travelled in one revolution, it is a circle, right? Yes or no? So force into 2 pi R. So this is joules. The power developed P is equal to work done by time. This time is already we derived. N revolutions are made in 60 seconds. For one revolution, how much time? That is 1 by n into 60. That should be equal to 60 divided by n. That is our change in time. So power is equal to work done force into 2 pi R divided by 60 divided by n. So force into R into 2 pi n by 60. Where what is 2 pi n by 60? 2 pi n by 60 we can call it as torque. Sorry, omega. And F into R is called the torque. Power we can write it as omega into T. This torque is called the armature torque. Here TA is equal to force into radius. Omega is equal to 2 pi n by 60 radians per second. And TA, this is a gross mechanical power which is developed by the armature. So that should be equal to EB into IA. EB into IA divided by omega. So omega is equal to, substitute omega is equal to 2 pi n by 60. That is equal to 9.55 into EB into IA divided by n. The units of armature torque is newtons. This is the first step. And one more thing, if you are substituting EB is equal to 5Zn by 60 into P by A in the above equation, TA is equal to 0.159 into 5Z into IA into P by A. So these two are the very, very important equations. 9.55 into EB into IA by N. This is first equation. And second equation, both are very, very important. So the question is, find the torque in Newton meter. Find the torque in Newton meter exerted by a 4-pole series motor whose armature has 1200 conductors connected up in a two circuit winding, the motor current is 10 ampere and the flux per pole is 0.02 Weber. The solution. So 4 pole means the number of poles are 4. Okay. And armature Z is 1200 conductors in two circuit winding. Armature current is 10 amperes. Flux is equal to 0.02 Weber. The armature torque equation 0.159 into 5Z into Ia into P by A, 0.159 into 0.02 into number of conductors is 1200. Armature current is 10. Number of poles is 4. And is it a lap winding or wave winding? So is given as a lap or wave. Find the torque in Newton meter except by 4 pole series motor whose armature has 1200 conductor connected up in a two circuit winding. The number of parallel paths is 2. So now I think you got the answer is 76.32 Newton meter. Next, what are the types of torques in a DC motor? Types of torques. We know that it is a armature torque. Yes, armature torque. And this torque is also called as a gross torque. Listen students and listen friends, there is a difference between the gross torque and net torque. Suppose if a person's salaries will be 30,000, that is called the gross salary. But some cuttings are there, that is tax or PF. After that he may get 29,000. The 29,000 is the net salary and 1,000 rupees is a loss only. Okay, anyway, provided fund we are at the final we are getting more. But if a tax is there, okay, assume that tax is 1,000 rupees, the 1,000 rupees is the loss, right? Loss, that is called the net. Similarly, here also some force or some power is required to meet the losses, that is called the mechanical losses is there. This armature torque is to overcome the lost torque and shaft torque. This shaft is just like a net salary and useful torque. This is called the useful torque. If I am drawing the armature, and armature is connected to load, the armature is coupled to a mechanical load, let us say that is called the wheel, we can apply a breakdown, the armature torque or generated torque. So there are friction and windage losses are there. Friction and windage loss. What is friction and windage losses means? Initially some friction is there. With that friction only it will be stable. Initially some force is required to rotate the armature. Some power is wasted, and also during running the wind will opposes the rotation of the armature. Due to that some loss will be produced. That loss is called the windage loss. Whatever the force which is developed in the armature is to overcome the friction and windage loss, and also called as the to meet the shaft torque. Okay, what is the net output of the motor? Output of the motor should be equal to shaft torque into omega. The difference between the gross torque and shaft torque is called the lost torque. It's called the lost torque. And in the next video, let's discuss the no load condition of a DC motor. Thank you.